If we want to find the rate at which the area of a circle increases with respect to the change in the circle's radius, we can take the derivative with respect to radius of pi r squared, which is the equation for the area of a circle. When we do this, we get dA dr equals 2 pi r, which, if you notice, is also the equation for the circumference of a circle. This is not just a coincidence. We can also find a visual explanation for this connection. Let's start with a circle with radius r and area a. If we increase the radius by an amount we'll call dr, which will be this length, we will also get a change in area, which we will call dA. dA is going to be the area of this ring, because the area of this ring is how much the area of the circle gained as a result of the increased radius. To find the area of the ring, we can unroll it so it becomes a trapezoid. This side is the inner circle rolled out, so it will have a length of 2 pi times r, because the circumference of the inner circle is 2 pi times r. The top side is the outer circle rolled out, so it will have a length of 2 pi times r plus dr. R plus dr is the radius of the outer circle, because the radius of the outer circle is the initial radius r plus the change in radius dr. And then the width of the trapezoid is just going to be dr, because dr is a change in radius. And right here, that is this side of, if you can imagine the ring being rolled out into a trapezoid. However, since we are trying to find the instantaneous rate at which the area changes, we need to use values of dr that approach 0. Therefore, this top side will have a length of 2 pi r, because this dr approaches 0. That means that this top side length is going to approach the same length of the bottom side length, because the two circumferences are going to be virtually the same when you have a very small change in radius. So as we use smaller and smaller increases in radius, this shape becomes a rectangle with a length of 2 pi r and a width of dr. Since the area of a rectangle is its length times its width, the change in area of the circle is 2 pi r times dr. So we can write that as dA equals 2 pi r times dr. Once again, this equation only works for infinitely small changes in radius. Now, if we divide both sides by dr, we get dA dr equals 2 pi r. Or in other words, the rate at which the area of a circle changes with respect to a change in the circle's radius is the value of the circumference at that instant. This method can also be used to find the derivative of the volume of a sphere with respect to the sphere's radius. If you do the same thing, you will find that the answer is the surface area of the sphere.